Yes, memory is a thing. It's a problem that we need solving as humans. We are quite fallible. And it's a problem that we need solving as systems. And Sarah Wooders is working, I believe, on memory and AI. And yeah, so let's find out a little bit about Letta. And over to you, Sarah.
Hi, everyone. My name's Sarah. Thank you so much for the introduction and for having me. Yeah, I'm just going to start off with a quick couple of slides to kind of motivate, like, why are we even building Letta? Like, what is kind of like the problem here? Because I'm sure, there's like a million different like frameworks out there. So just want to kind of provide that context, but afterwards it'll be a bit more hands-on. So feel free to bring out your laptops. So yeah, just some really quick background on Letta. I would say Letta is basically the platform for stateful agents. So we work with a bunch of different customers to basically create and run these agents for their applications. We work with Built Rewards, which is a rent payment credit card company, to build recommendation agents that learn from their users. And then we also work with another company, 11x, for example, that's building deep research agents on Letta. So there's a lot of different applications that you can do with Letta, but I think what we really specialize in is these long-running stateful agents that actually learn over time. And so I think in the beginning of this conference, there was already the discussion of like, what are agents? And I think there's been a lot of back and forth on this meaning. I think it's been redefined many times. I think a pretty reasonable definition was from OpenAI, where they say an agent is an AI application consisting of a model with instructions, tools, some runtime, etc. So this is, I think, a pretty common definition of an agent, though there's of course a lot of them. But I think like what all these definitions actually lack is, what about state and what about memory? And these are actually concepts that were very core to the original definition of an agent. When you look at agents from back in RL days, or maybe even from economics, the agents themselves had their own sense of identity. They would learn, they had state. But right now, I think when we talk about agents, we talk about them purely in a state, as essentially stateless functions. And I think because we're missing this piece, we also are missing this incredibly important piece, that is, what about the ability to learn? You obviously cannot learn if you have no memory. And I would actually even go as far as to argue that the biggest missing piece in terms of this dream of AGI or having like these AI coworkers that go beyond just workflows is actually learning. And the reason for this is that I think agents today, they're actually incredibly intelligent. They probably know more, are better at solving math problems than any one of us in this room. But they have this severe limitation of they basically are constantly forgetting. So if you're choosing between hiring Albert Einstein, but he forgets everything every 10 minutes, versus like an average Joe, but he can actually learn, I think most people would actually choose that person who can learn, because there's very little that you can do when you're in this constant cycle of forgetting. And I think, if you're into movies, I think both 50 First Dates and Memento are pretty good examples of like, what would a human that's constantly forgetting look like. 50 First Dates is about this woman who like every single day she forgets what happened the previous day. Memento is about this guy who like forgets what's happening every 15 minutes, so he has to like write everything down. But this is basically the state that current LLMs are in, which is why I think a lot of the use cases today kind of limit them primarily to more workflows. They're not really like AI coworkers in the ways that many of us have perhaps dreamed that they would become. And I think not only do agents not learn, it's actually even worse than that. They degrade over time rather than getting better. So you might have noticed if you're running like coding agents, or like if you're chatting with a chatbot for a really long time, that the agent seems to kind of get like crazier and crazier, or like worse and worse. You have to like wipe or reset or recreate your agent. And this actually isn't just coming from your imagination. It's actually like a measured effect. Chroma had a pretty good, I think, post on like context raw and like what can happen as the context gets longer and longer. We also had this benchmark called Recovery Bench, which was basically measuring how well does an agent do from a fresh state versus like a sort of polluted or existing state. And you can see that, Claude Sonnet does like fantastically from like the fresh state, but the performance really severely drops once you have an existing history that maybe has some mistakes. And so this is another really big difference from humans, where with humans, like typically if you make a mistake, you learn from your mistake. So having that experience helps you, right? But with agents, it's the other way around, where having that experience actually degrades the performance. And yeah, another interesting result from this was, GPT-5 actually, I think the OpenAI models are better at recovering from bad states than the Anthropic models. So I think in the orange bar, like GPT-5 is actually the best. So that was kind of a surprising result. And so how do we actually bring about learning into agents? So I think when people talk about learning or AI learning, the majority of the time they're talking about model parameters. So you basically, maybe you do something like RL, you do some fine tuning. There's also methods for parametric memory. But I think a lot of these methods are talking about updating parameters. But I think in reality, this is very difficult to actually productionize or kind of use. Because there's a couple problems. One of them is I think it's actually very hard to do online or regular updates of parameters just because it's very difficult to evaluate what has the model actually learned. That's a very difficult pipeline to set up. And then also, I think most people today are using frontier models who use GPT-5, Claude 4 Sonnet, et cetera. And in those cases, you don't really get to control the model parameters. They might have some limited fine-tuning APIs, but you're much more limited with what you can do. So I think what the new LLM era has introduced, though, is there's kind of a new way that we can bring learning into agents. And that's essentially learning things into the context window. So I think people are calling this a lot of different things. I've heard people call it system prompt learning, memory, agentic context management, context engineering, et cetera. But I think a lot of these phrases are kind of circling around this similar idea of what if you can learn information into the context window itself. So in the same way that if you get some information, you update your model parameters, instead you update the context window to kind of represent that information. So it's kind of like learning tokens rather than parameters. And I think this actually has huge practical advantages because it means that, first of all, it's extremely interpretable. It's just English or whatever language, so you can just read it to tell if it's right. You can apply LLM as judge. And then it's also model agnostic. If you learn some context, some information, you can pass that to OpenAI, you can pass it to Anthropic, to Gemini, open models, whatever. But it's basically a much more flexible way to learn information. So I think we really believe that this is the future, and this is a big part of how we design Letta as a platform to basically make it really easy to build these agents that are able to learn updates into the context window. So I'll also show this agent in a second, but a real-world example of this is a new agent that has kind of been training for about a month. I think once you have agents that can learn, you can also start talking about training them. So Ezra is our support agent that has been in training for approximately a month. He listens to everything that happens in Discord to basically learn about all these different things in Letta. So this is kind of peering into his context window and all the segments of his context window. And you can see that he's learned all these things, the knowledge gaps, the Letta agent lifecycle, he even learns things about the different Discord users and what they're building. And so I think Ezra actually really feels like something that was fine-tuned, even though everything is actually being done in context. So I'm just going to hop over to a demo now. So let me exit this. What? Oh. Okay. Is that big enough for people? Okay. So this is the Letta developer platform. Feel free to kind of open this up. You can just sign in and create an account at app.letta.com. But this is essentially our hosted service for creating these stateful agents. So everything I'm going to do in here, you can also do from our API and SDK. So you can copy your API keys here. And then these are some example snippets of how you create the agents and message them. But obviously, I think it's a little easier to just see everything from the UI. So I'm going to do everything from the UI. So to just show you a really simple example of learning, I'm just going to create an agent. And let's just create a companion agent. So this agent is kind of structured to just have one-on-one conversation. And yeah, I think this view is often a little overwhelming, but there's a lot of things that you can configure, so that hence there's a lot of configuration. But this is what we call the agent development environment. It's essentially a UI designed to help you as a developer create these agents that have state and manage context. So I can change the name, I can change the model, it's model agnostic, so let's maybe change it to 4.5 Sonnet. Here are the system instructions. There's configurations like whether or not to do parallel tool calling, the temperature, etc. And of course, there's also custom tools. And you can also attach MCP into this, but this agent right now just has some simple memory-related tools and then also conversation search. And on this right-hand side, we also have the memory blocks. So this is essentially the in-context memory of the agent. So if I open this up, you can see that right now it doesn't really know anything. It just kind of has some like pre-filled stuff saying like, I don't know anything, I should learn some stuff. And then these blocks also have a description and a label associated with them, as well as a character limit. So this is kind of saying like, we're allocating 20,000 characters inside of the context window to storing this information. And there's also a persona, which is essentially like, memories that the agent has about itself. And this can be customized, so you can add your own blocks and kind of structure the memory in different ways. So as a really simple example, I can be like, hi, my name is Sarah, and today is my birthday. And so I message the agent this. It's going to spend a little bit of time thinking or reasoning. And then because it's learned some new information, it's going to call this memory replace tool. And you can see that there's an update that just happened to the human section of the memory blocks. And the reason why that happened is because this tool is basically designed for overwriting the memory blocks. So it decided to basically replace this string that previously existed, and then it is updating it with this string. So that's basically how it's managing to rewrite its own memory through using tools. And one thing that we really kind of prioritize in Letta is helping you understand like what is exactly in the context window. So you can pop over this context window viewer, and these are kind of all the different, actually, is everyone here familiar with like a LLM context window? Okay. Basically, this is like the input or the program that goes into the model. And they can be quite long these days, especially as context sizes grow. So this is kind of how we organize the context window. There's obviously like the base system instructions explaining to the agent like what is like the memory, what's the file system, the basic abstractions in Letta. There's also the tools, so you can actually see like the raw schema of the tools in here. There's summary about external metadata that's available, and then there's also the core memory. So these are basically the blocks that have been compiled into the context that represent the information that the agent has learned. So for example, it's like, I mean, this is not true, but it's like learn that my birthday is today and my name is Sarah. And then we haven't done any summarization yet, but if we did do some compaction, the summary would go in here. And then there's, of course, like just the raw message buffer. So you can see all of this raw. And I think this is actually really important for understanding exactly why. I think 90% of the time when your agents, something goes wrong, you can actually debug it to something that's wrong in the context. So we try to make that really transparent. And of course, Letta is model agnostic, and I think one of the biggest benefits that you get from Letta is being able to control your own state and context. So I can actually download this agent as an agent file and send it to my friend, and they can upload it back. So this can be really useful if you're moving agents between servers, like a self-hosted server, et cetera, or just like for debugging. And then, yeah, I also wanted to briefly show, so this agent's not very interesting because it's basically like an agent baby, right? Like it has no experience, it's brand new. But Ezra, which I just mentioned, is a much older agent. I think he's existed for about a month. And so with Ezra, he's like basically getting this like stream of updates from the Discord. And so, he can choose to ignore something. He can choose to insert things into his memory. And so because of this, the memory is much more complex and detailed. So this is kind of like how the memory starts to look over time as a lot of updates are happening. So, it's learned things like API integration patterns, communication guidelines. It also knows like who our team is, and so it's able to prioritize listening to feedback from people on our team as opposed to, random people on Discord. And then it's also able to essentially like continually write down all these notes about Letta and like the different patterns in Letta. It's also able to like, even things that aren't necessarily documented, like certain gaps in the API, it's able to learn that just from reading all these things on the Discord. So this is really, I think, a pretty good example of how an agent that's able to learn starts to look very, very different from just a vanilla agent. And one last thing I wanted to show is we have a new experimental project, which is essentially allowing Letta agents to connect to your local environment. So it's Letta code. And I'm just going to quickly show this. So you can actually use the Letta CLI to just like connect to like an existing agent. So I can connect to like this agent. So everything is accessible through the API. So I can like connect to this agent with a unique ID. And so is this big enough for people? Okay. Oh, this is Ezra. Okay, I don't want to talk to Ezra. But yeah, I can basically like message, in here, and it's basically connecting to the same backend API service. So I can connect to the CLI in the same way that everything's connected in the UI here. But one thing that we've kind of been experimenting a lot with is like making sure that Letta is actually good at coding. Because I think if Claude 4 Sonnet is really good at coding, but Letta's not, and it's running on that model, that means that we've kind of degraded it. So I think one thing we really think about a lot is making sure that we are only adding capabilities on top of the models and not actually regressing things with the way that we've designed our harness. So to kind of show you a quick example, here's like a linear ticket that we haven't gotten to yet. And let me just create a new agent. So this is basically creating an agent on Letta Cloud. And I'm going to paste this in. And so the big difference between this agent and the agent that I was, oops, I guess I need to fix that UI bug. A big difference between this agent and the other agents is that it actually has access to my local file system. So even though it's running in the cloud, it's still able to do things like grep to search through all the files locally. And it's kind of meant to be sort of like a Claude code, except actually stateful and able to like form memories and persist over time. So while that's running, I can actually hop back to pulling up this agent. And so this is the agent that's basically like running this coding task right now. And you can see that all these operations that are running is actually persistent in the cloud. So you can see the full message history. You can see it running and approving things. And the nice thing about this is that I can go back and switch like from a different machine, or also like program the memories to work in a certain way, as we do with like the standard Letta agents. And the reason why we're able to do this is because for the tools, we have basically different modes of execution. So this agent has a lot of tools actually, but some of them are like basically server-side tools. So for example, fetch web page or conversation search, these both execute on the server. As opposed to all these other tools, we actually consider them like variants of human in the loop. So when the agent wants to execute one of those tools, for example, like grep or ls on my machine, it actually goes back and asks for permission from the client and asks for the client to execute that. And so that's how I'm able to have this like cloud agent basically access my local computer to do things like make code suggestions. So it just requested to edit a file, and I approved it. So yeah, the other nice thing about this too is like you don't have to ever compact. I don't know if you've ever used Claude Code, like the compaction kind of destroys your agent a lot of the time. But this is using like Letta summarization in the back end. So you can customize the context window budget. So I can like lower this to be like just like 100,000. And then like as the agent kind of runs, it'll like actually like compact things and make sure that or actually I think it just happened. It'll make sure that the number of tokens is always within that budget. So yeah, this is like a really new tool. Would recommend trying it out. It still has a couple rough edges, but I've been using it for about the past week, and it as like a Claude Code replacement, and it's been working pretty well. So yeah, that's all I wanted to show you guys, and happy to take any questions if there's time.